Good afternoon, guys. Today we're going to be talking about intervals of increase and decrease. This is something we talked about in Algebra 1, so it's kind of a revisiting of it. We're going to, of course, add our little flair to it and talk about how it applies to Algebra 2 as opposed to just Algebra 1. Essentially, what we're looking for in intervals of increase and decrease, we're talking about, that's always going to be talking about your x-axis. So ignore the y-axis. Do not use your y-coordinates. You're only going to use your x-coordinates to determine your intervals of increase and decrease. Now, the first example we got is something we saw in Algebra 1. It's a simple simple quadratic problem. Let's say parabolic, sorry. A simple quadratic graph. We start off, and just like we do when we read text, when you read your text messages or you read a book, you always read from left to right. And that's the same concept when we're talking about intervals of increase and decrease. So, the first thing we want to do is look at this graph and start on the left side of it. So I'm going to start here where this arrow is, and basically I'm going to trace it. And as I'm tracing it, I notice that my pen is going down. So that means that this going from left to right, as I'm moving from left to right, my pen is going down. So this is a period of decrease or interval of decrease. So we're going to start off with decrease. Now, what we have to do is we have to talk about that this arrow means that it keeps on going and going and going, correct? So that means that it keeps on going to the left. It's going to be slow, but it's eventually going to get all of the x values on the left side of the graph. We call the left side of the graph negative infinity. So what we're going to do is when we write our interval of increase and decrease, we're going to write a parentheses whenever we're talking about infinity. Okay? Now, again, I'm not going to quibble over it, but if you have a higher professor or in college, they may be more of a stickler for notation. Here, I'm just concerned with you getting the right numbers. So if you were to mess up and put parentheses as opposed to a bracket, I'm not going to trip. But again, another math teacher might. So I do want you to know how to do it correctly. But again, if you make a little mistake, I'm not going to trip about it. All right. So, like I said, this part of the graph it talks about the negative side or the left side of our graph called negative infinity. So we're going to basically saying we're going from negative infinity, and then we're going to stop where it stops going down at on the y-axis. So on the x-axis. So as you see, my pen stops here. So then I basically, if you want to, draw a dotted line up to the x-axis, and whatever number your dotted line touches is going to be the ending point of your interval of decrease, which in this case is 4. Okay, so then we would write comma 4. And this is where we put a bracket. So anytime we're dealing with infinity, whether it's negative or positive infinity, we use a parentheses. And if we're dealing with a finite number, such as 4, 7.6, negative 2.2, negative 1/2, something like that, a rational number like that, then we're going to use a bracket. And again, like I said, I'm not going to trip over it, but I do want you to be able to know how to correctly notate an interval of increase and decrease. Now, just like in physics and everything else, if something goes down, then the convention usually is what goes up must come down. In this case, if we have a period of decrease, we've got to have a period of increase, because with all of these functions, all these polynomial functions, they're going to have at least one interval of increase and one interval of increase. Okay, so again, they're going to have at least one interval of increase and one interval of decrease. All right, so then we move on to when we get to 4, now we start tracing. Again, we're going from left to right again. We're still going to the right. So look at my pen. My pen is going up, so that means that's increasing. Okay, so we're going to write I for increasing. And because we're starting at it positive 4, we're going to do our bracket, comma, and then eventually this will get all the positive numbers or the right side of our x-axis. So therefore, it's going to be positive infinity. Okay? So for example number 1, our interval of increase and decrease, our decrease was negative infinity, comma 4. Our increase was 4, comma positive infinity. Now some on Schoology or some other text, you may not see a positive sign here. You know, anytime there's not a sign, then the number is automatically positive. So I will accept either one. If you put a plus sign here, that's fine. If you don't put a plus sign here, it's also correct. I just put a plus sign so that way you can see the difference between negative infinity and positive infinity. Some people need to see that. So That's basically how I'm differentiating between the two infinities. Okay? So that was, again, a simple parabola. So we're going to do example number 2. Now this time, in example number 1, our parabola opened up. So basically the convention is if you have a quadratic function or an even number function, then your graph is always going to point up. And you're going to have an interval. You're going to start with your interval of decrease. However, what if you have it pointing down, like example number 2? Example number 2, again, is another parabola, therefore a quadratic function. However, it's pointing down. So if we're going from left to right again, well, as we go left to right, what's my pen doing this time? It's going up. So that means that we're going to start with our period of increase first. And again, because we're starting off on the left side of our graph, we have to talk about negative infinity. Okay? So it's going to be, again, parentheses, negative infinity, comma, and again we're going to go to the stopping point. When it stops going up, again, as a little helpful tool, what I do is I draw a dotted line down to the x-axis. It's supposed to be at 1. I apologize, it's a little off. I did this without graph paper, but basically we're going to call that negative 1. Okay, so negative 1 bracket. So our interval of increase for this one is negative infinity, comma, negative 1. Okay, so again, just like with the regular physics convention, what goes up must come down. So when it stops going up, we start seeing it going down. As my pen traces the graph, it's going down. So that's going to be decrease. And then we're going to say negative and 1, because again, that's where we started from. Okay? Wherever you start, wherever you stop, that's where you start. Okay? So again, negative 1, and then this time, because it's eventually, even though it's pointing down, remember what I said, we're looking at the x-axis. Eventually, this graph, if we could follow it out, it would eventually get all the x's on the right side of our graph. Therefore, positive infinity. Okay? And see, I just made a mistake myself when I was talking about brackets and parentheses. Okay? So for this interval of increase and decrease, it's going to be interval of increase is negative infinity, comma, negative 1. Decrease was negative 1, positive infinity. And again, it depends on the shape of the graph. Okay? So these are with quadratics. With quadratics, you're always going to have one increase and one decrease. Now, when we get into other polynomials, we're going to see multiple increases and decreases. That's the algebra 2 twist. Okay? So let's move on to example number 3, so that way you can see the twist I was talking about. So as you can see, we have multiple turning points. Okay? Turning points are basically whenever the graph changes direction. Instead of going up, it goes down. Instead of going down, it goes up. So when you have multiple ones, then that means you're going to have multiple increases and decreases. Okay? So let's start off with this one. All right? As my pen starts on the left side of my graph, I start doing what? I start going up. So that means we're going to start off with a period of increase. Okay? So again, because we're dealing with the left side of our graph, we're going to do parentheses, negative infinity. Okay? When we get to the first turning point, which is our stopping point, we draw a dotted line, and again it goes down to negative 2. So then we're going to say negative 2 is the stopping point for this interval. Okay? So at negative 2 on the x-axis, it stops increasing. Okay? So again, remember I said with intervals of increase and decrease, we do not worry about the y-axis. We only look at the x-axis. We are following it. Yes, it's going up and down, but we're talking about as we are moving along the x-axis. All right? So again, what goes up must come down. So again, we're going to start here. So we'll come down here and put a decrease starting at negative 2. And what does it start doing? It starts decreasing, and it goes all the way down to positive 1 on the x-axis. Okay, so again, that's going to be positive 1. Now, I'm not going to write a positive sign here. I'm just going to write 1. Okay? And then what happens after that? After that, it starts going back, what? Up. So then, we're going to come back up to increase, and we're going to put positive 1. And then, because it's going to eventually get all the positive x's, we're going to say positive infinity. I'm not going to write the positive sign this time, just to show you how it is. So for this one, In order for this question to be correct, in order for you to have correctly identified all the intervals of increase and decrease, you would have had to list it. For your increase, there were two intervals, negative infinity to negative 2 and positive 1, positive infinity. So basically, and then lastly for your decreasing, it's going to be from negative 2 to negative 1. So it's basically saying that if your x value is between negative infinity and negative 2, it's going to be on the increasing part of the graph. Or if it's between 1 and positive infinity, again, it's on the increasing part of the graph. If it's between negative 2 and positive 1, if your x value is between those two numbers, that means it's on the decreasing part of the value of the graph. Okay? So that's increase and decrease in a nutshell. So again, you can rewind this video as much as you need to, or go back to a part if you need to. So this will help you answer questions about increase and decrease that are going to be in Schoology, both on your quiz and test. So our next lesson will be starting on classifying polynomials. So stay tuned.